Welcome. In this video, we are going to test the hypothesis about mean, that is inference concerning the population mean mu when small sample is considered. Okay, when we consider a large sample, we calculate with the help of a standard normal distribution, and when the sample is small, we go with student t distribution. Okay, here this is known as population normal. Okay, and the variance sigma square is unknown in the case. In that case, what do we do? In place of sigma, we make use of the sample variance s, sorry, sample standard deviation s to proceed with the calculation. When we use the statistic, we need to be careful with the parameter nu, which is n minus 1. Okay, at the level of significance alpha, we are going to test it just like in the previous case. Here also we have the three cases in the alternate hypothesis. Okay, there we had everything with the help of z. Here we have it with the help of t. That's it. Okay, even this you can look into it. Now let's directly get into the problems. Okay, before getting into the problem, we will have to pay some attention and understand the things that if n is large, we will make use of that statistic, no matter whether sigma is known or not. If sigma is not known, you can very well make use of the sample standard deviation as an estimate of sigma. Okay, and the statistic that you know very well, and when n is small, we make use of t statistic. Okay, we come to the problem. Here it is given that a random sample of 5 pins from different production lots, we want to test whether the fat content of a certain kind of ice cream exceeds 14 percentage. Okay, what can we conclude at 0.101 level of significance about the null hypothesis? Mu equals 14 percentage if the sample has the mean 14.9 percentage and the standard deviation is 0.42. So basically the information given to us is n equals 5. Okay, mu naught is 14.9 percentage and s is 0.42 percentage. Here the null hypothesis is to test whether this mu equals 14 percentage against the alternate hypothesis h1 exceeds 14 percentage. So mu is greater than 14 percentage. So this is the, now that we have set up the problem, and also note that the level of significance here given is 0.01. Okay, so here we assume that the population sampled is normal, we have a small sample. Okay, and this mu greater than 1.4, which means it is basically a right tail test. Okay, so right tail sorry, after this point, what is going to be that? This is what we are going to check. Okay, now that we will have to use the test statistic. Okay, so test statistic t is x bar minus mu naught upon s upon under root n, isn't it? So this is, sorry, this is basically x bar, that is the sample mean is, isn't it? So x bar minus mu naught upon s under root n. So it is 14.9 minus this 14 is the thing that you are, that we are testing, 0.42 divided by under root 5. So when you perform the calculation, you get 4.791. Okay, now from the table we need to calculate t alpha. Okay, for what? For alpha is 0.01 and nu is n minus 1, which is 5 minus 1, that is 4. Now let us go back to the table and see t table. Yeah, so now let me use some other color. So 0.01 in the right hand side, right? So it is the value that we are looking for. And what was our new? New is 5 minus 1, that is 4. Okay. So this is the value 3.767469. Okay. 7469. So from the table, we have read that it is 3.7469. Okay. Note that our t value is greater than t alpha. Okay. When t is bigger than t alpha, what do? This is the alternate hypothesis that we have. This is the condition that we have. So we can very well reject the null hypothesis. Okay. Hence, reject H naught. So what do we conclude? Therefore, the fat content of a certain kind of ice cream exceeds 14 percentage. And note that in testing of hypothesis, we are dealing with some practical situation. So when we are dealing with some practical situation, at the end you will have to give the statement or the statement which is the conclusion after your calculation. So basically you will have to write some statement just like what I have written in the last. And for the time being, I will not write these kind of statements for every problems. I will explain you the ideologies of all these things, but make sure that when you are giving these things for your semester examination, if suppose, you will have to write it down. Okay. So the conclusion, the inference that we make is important. Okay. Moving to the next problem. Here we have a random sample of 6 steel beams has mean compressive strength of 58,392 units with a standard deviation of 648 units. With this information and the given level of significance is 0.05, we need to test the true average compressive strength of the steel from which this sample came is 58,000 units. So basically here the given information are n is 6, okay, x bar is 58,392 and s is 648 and alpha is given to be 0.05, okay, and the null hypothesis, that is h naught, which is mu equals 58,000 against the alternate hypothesis, which is h1. Do we have any information for this one? So here, if you go through the problem, we need to test whether this is 58,000 units or not. So in that case, our mu is not equal to 58,000 is the alternate hypothesis. Suppose if you are specific that it is bigger than 58,000 or smaller than 58,000, in that case, you will have to go for a one-tiled test. Okay. This is not equal to this quantity. So we will go for a two-tiled test. Okay. Now test statistic is t is x bar minus mu naught divided by s upon under root n. X bar is 58,392 minus 58,000, this is what we are checking, upon 648 divided by under root 6. When you perform this calculation, you get 1.482. Okay. Now we need to read from the table. Okay, what value should we read? That is important, right? So coming to this theoretical stuff, when we have this mu equals mu not equals mu naught as your alternate hypothesis, we will reject if absolute of t is this thing or absolute of t is bigger than this thing. So as a cumulative thing, what we can write. So if you take absolute, both becomes positive, isn't it? Okay. Uh, Let me just negate it. So minus t bigger than t alpha upon 2. Here already we have t is bigger than t alpha upon 2. As a cumulative thing, what we can write it as absolute of t bigger than t alpha upon 2. So this is what we are going to check. No matter whether we get t as a positive quantity or negative quantity, we will read t alpha upon 2 from the table and see the absolute value of t is bigger than this quantity. Okay. Now our alpha value is 0.05, isn't it? Now let us get back to the table. Okay. And now let me use some other color. So our alpha was 0.05, but we need to read t alpha upon 2. That is t 0.025 is the thing that we need to do. So this is the one. And what was our new? New is n minus 1, and n was, we had 6 tails. 6 minus 1 is 5. So 5. So this is the value 2.5706. So from the table we have read T alpha upon 2 is 2.5706, okay, for alpha equals 0.05 and nu equals n minus 1, which is 6 minus 1, that is 5. Okay, and here we observe that absolute of t, which is 1.482, right? This quantity is not greater than t alpha upon 2, which is 2.5706. Okay, so in that case we cannot reject null hypothesis, therefore we accept null hypothesis. So when we accept null hypothesis, with which what can we conclude? We conclude that the true average compressive strength of the steel is 58,000 units. So we conclude with this. Thank you.